So this is a video looking at chapter 14 on lymphatics and immunity. So the lymphatic system really is almost like another circulation system. It is a network of vessels that bring fluid that has left the bloodstream and entered the interstitial area back to the bloodstream. We're going to see in circulatory system that at the capillaries of the blood capillaries, more liquid leaves the capillary than comes back. The lymphatics take care of that excess. Without it, you would have too much interstitial fluid, which is edema, swelling. It's also involved with taking fats from the digestive system because they don't enter circulation very well because they're not water soluble. It's also the place where immune surveillance happens. It's so there's groups of cells and chemicals that are involved with the immune system. So that's why these things are done together, and the immune system that protects the body against disease. So we'll start out with the circulation. So the circulation of lymph starts at the lymph capillaries. Now we have lymphatic capillaries virtually everywhere where we have blood capillaries because their job is to pick up the excess interstitial fluid, and that's where it comes from, is the blood capillaries. So they are intertwined. We'll see in the next picture. The difference between a lymphatic capillary and a blood capillary is a blood capillary, blood passes through. It comes in at the arterial end, leaves at the venual end, and is circulated by blood pressure, by the pressure of the heart beating. Lymphatic capillaries are close-end tubes that extend into the interstitial spaces, and they have these flaps, these openings in them that when there's excess interstitial fluid, the flaps get pulled open and the fluid can enter the capillaries and become lymph. The interstitial fluid comes from the blood plasma, but it doesn't have any of the plasma proteins. When it enters the lymphatic vessels, the lymphatic capillaries, it's called lymph. But really the only difference is the location. The difference between interstitial and lymph is just where we find it. So this picture shows these closed-in lymph capillaries. They're very permeable. They're much more permeable than blood capillaries. And so they pick up, not only do they pick up the excess liquid, but any particles that are in that liquid. So proteins, cellular debris, bacteria, viruses, cancer cells, anything get picked up by them. Now, the capillaries all come together and they form lymphatic vessels. And the vessels are the same as veins, or very similar. They're thin, walled, but they have the same endothelial lining and a tunica media and an adventitia externa on the outside. And they have valves like veins, so that they're the lymph flows in one direction. Now, unlike the circulatory system, where 5 liters a minute pass through the entire circulatory system, the lymphatic system is a couple of liters a day. It's much, much slower. So there's way more valves. The valves are closer spaced than in veins. Now, the larger lymphatic vessels, especially when they get, we'll see, to the places that kind of bend, like the knee and the hip, the elbow, the armpit, the neck, the vessels pass through these organs called lymph nodes. And they go through chains of lymph nodes, and the vessels just keep on getting bigger and bigger and bigger. Once they're through all the nodes, we call them lymphatic trunks. And then the trunks come together to form lymphatic ducts. So it runs parallel. The circulatory system is here, the lymphatic system is here. So these are the lymph capillaries becoming lymphatic vessels, passing through lymph nodes. The lymph keeps on flowing up through the various lymph nodes into the trunks and then the ducts, and then that joins onto veins just before the superior vena cava, and the liquid is returned to the bloodstream there. So this is just a picture of a valve within the walls of the lymphatic vessel, and you'll notice how thin the walls of that vessel in fact are. So there's a bunch of trunks, and I'm not going to, for this course, we're not going to bother learning the names, but they're named after the areas where they're found. So we have a left and right lumbar trunk, we have an abdominal trunk, we have a bronchiomediastinal trunk on both sides, we have a brachial from the arms, we have a jugular left and right from the head. But the point here is that these trunks all empty into one of two collecting ducts. On the right-hand side, we have the right lymphatic duct, and that takes the lymph from the right side of the head through the jugular trunk, the right arm through the brachial, and the bronchiomediastinal of the right side of the thorax. It goes into this right lymphatic duct, and then the right lymphatic duct joins into the right subclavian vein, right where the jugular vein and the subclavian vein join to make the brachiocephalic vein. On the left side, it's called the thoracic duct. The thoracic duct does the left side of the head, the left arm, the left thorax, and everything below the diaphragm, both legs and the entire abdominal region. So it's an uneven distribution. If we look at a picture, the part that's kind of in this pink all goes to the right lymphatic duct, which goes into the right subclavian vein. The legs, the crotch, the pelvis, the abdomen, the left side of the chest, the left arm, and the left side of the head all drain into the thoracic duct, which drains into the left subclavian vein. So again, lymph is the fluid that's in the lymphatic capillary. It really is just interstitial fluid. It's very similar to blood plasma, but it doesn't have the plasma proteins. So any fluid that leaves the blood capillaries becomes the tissue fluid, the interstitial fluid, that is not taken back into the bloodstream, ends up in the lymphatics. Now this is very useful because along with that fluid, comes any cellular debris. And this gives the body a chance to deal with that debris, to deal with any pathogens that are there, or any cells that are malfunctioning that get pulled up, or any excess proteins and things like that. And so the lymph is cleaned of these things on its pathway back towards the circulatory system. Now, what drives the lymph, because there's no heart, there's no circulation, what drives the lymph is what's called hydrostatic pressure of the tissue fluid. So that's really pressure by the presence of the fluid in the interstitium and the size of the interstitium. You can increase the lymphatic drainage and the lymphatic flow by putting pressure on the tissue, like via massage or support hose and things like that. So elderly people that have poor ability to bring liquid back via the blood capillaries end up with swollen ankles. So they elevate their feet, like they sit with their feet up to try and use gravity to help move the lymph towards the core. Or they wear stockings that basically squeeze the tissue so that it increases the pressure and moves the lymph. Or they have people rub their feet and massage their legs, or all of the above. So it's a common problem that lymph flow gets disturbed during surgeries. And oftentimes people get edema, and it may be very long lasting. One of the big places that there's problems is post-breast surgery. If they are removing a tumor, a breast tumor, what they do is they also remove lymph nodes in the chain because they want to see if the cancer spreads. And cells from a tumor will break off and end up in the lymphatics, and they spread to other organs via the lymph. So by looking to see if there's cancer in any of the lymph nodes, we can estimate the likelihood of cancer having spread to other places. It's a necessary thing, but often it results in edema in the arm and in the chest of post-surgery because the lymph flow is disturbed. Oftentimes there's problems with lymphatic drainage from breast augmentation surgery. People that have breast augmentation often end up with edematous problems because of the disturbing of this particular chain of axillary lymph nodes, the lymph nodes in the armpit. So the lymph flows this way, and that's a critical thing. Now, within the lymphatic system, we also have lymphatic tissue and lymphatic organs. Now, like lymph nodes, for instance. Lymphatic tissue is reticular connective tissue. It is tissue that is has a lot of spaces in it. As you remember from last semester, reticular, ret, and net are the same word. So reticular means net-like. So the valuable thing about this is the space. There's lots of space within reticular tissue, within lymphatic tissue, for the fluid and for cells like macrophages and lymphocytes to do their work. Um, so we find it almost everywhere in the body. Some of it is just diffusely spread throughout other connective tissues, like areolar connective tissue. There will be little areas diffusely spread through that. And we tend to find this along points of entry into the body. So like along the mucosa of the digestive system, of the respiratory system, of the urinary system, of the reproductive system. The mucosa is the tissue, the epithelial tissue that separates the outside of the body from the inside of the body. Well, you want to catch any invaders right at the border, so that's where you're going to put the surveillance. And so we call this mucosal associated lymphoid tissue, or MALT. Now we also have aggregations of lymphoid tissue where there's big patches of it almost. Along the intestines, they're called Peyer's patches. There's a big one right where the small intestine enters the large intestine called the appendix. The tonsils in your nose and your nasopharynx and your oropharynx are also accumulations of this lymphatic tissue and are looking at kind of sampling the liquids that are passing through to prepare for any pathogens that might be found there. Now, some of this lymphatic tissue is actually incorporated into organs. They have capsules of dense connective tissue encapsulating it. And so that's things like lymph nodes and the spleen and the thymus. So lymph nodes are these little bean-shaped things. They have a bunch of lymphatic vessels going into them. Those are called the afferent vessels. And they have a couple of efferent vessels leaving them. There's always more afferent than efferent because it creates a traffic jam and slows down the flow of lymph, so that there's more, the lymph spends more time in the lymph node and then can be dealt with by macrophages and lymphocytes to deal with anything that's found in the lymph. They look like this. These are the afferent vessels. These are the efferent vessels. There are trabeculi, little walls in here. We won't go through it, but the lymph has to kind of go through this maze to get out. It gives surface area, it gives time. Found within the lymph node would be lymphocytes, macrophages, and various cells that are used to defend us. Here's a photograph of an actual lymph node with the afferent and the efferent vessels. I always find it interesting. The actual photographs are not as straightforward as the excuse me, the neighbors are, no, maybe not. It's not as perfect as the pictures, obviously. Okay, like I've already said, the lymph nodes are found kind of in chains, kind of near the roots of the limbs. Kind of, there's congregations, concentrations of them in the cervical region, in the thoracic region, in the armpit, axillary region. Supratrochlea means above the hip, in your abdomen, in your pelvis. Inguinal is in your crotch, in your groin area. There's also often some around the elbow, sometimes around the knees. The biggest ones are the inguinal, the abdominal, the axillary, cervical. Okay, so what do? They filter the lymph. They provide a place for immune surveillance where the macrophages and lymphocytes live and work. If there's a need, and we're going to see this in immunity, lymphocytes will clone and proliferate there. And lymphocytes attack viruses and any parasites or anything like that, any pathogens. The macrophages eat them and get rid of them. So we're going to talk about the thymus in a little bit when we talk about the lymphocytes in adaptive immunity, but it's considered a lymphoid organ. It is found kind of behind the sternum and above the heart. In children, it is very active. This is where your immune system learns what to do. By the time you're an old, elderly person, it has shrunk down and is not doing very much anymore. And that's why elderly people are more susceptible to infections and disease compared to kids. It's found right here. Just a photograph of it looking through. So the lymph nodes clean and filter and deal with lymph. What's going to do the exact same job for blood is the spleen. Now we have lots of lymph nodes because lymph moves so slowly. But blood, because it moves so quickly, we really need only one spot to do it, and that's the spleen. So the spleen is found in the upper left. It's like a large lymph node, except there's blood, not lymph in it. There's a white pulp where there are lymphocytes and macrophages and things like that, and doing immune surveillance of the blood. There's red pulp, which is the place where old red blood cells are removed. There's macrophages that eat those old red blood cells, and there's some lymphocytes, but there's a lot of red blood cells there. Because the spleen filters the blood, deals with any pathogens that might be in the blood, but it stores platelets, and it is the ultimate resting spot for damaged red blood cells. That's where they get removed. So that's a big job of the spleen, is removing old blood cells. I'm not worried about the histological structure of it, but fundamentally blood comes in, passes through these spaces, and then leaves. And within these spaces is where the filtration and such happens.